In this video, we are going to continue to discuss the topics of Chapter 11. In this instance, we are going to learn how, if we're given the structure of an alkane, we can find the name, or if we're given the name, we can draw the structure. So, when it comes to alkanes, understand that alkanes can be in straight chains. So, for example, when we look at the top right molecule, we see that that molecule contains 4 carbons. 1, 2, 3, 4. Having 4 carbons in a row means that the prefix to symbolize those carbons is going to be bute, and because this is an alkane, is going to end in ane. So the name of this compound is butane. Now, understand that if an alkane has 4 or more carbons, all those carbon atoms and hydrogens can be rearranged in different positions. So, for example, the molecule that it is in the bottom, it is also an alkane. And it actually happens to have the same chemical formula of the molecule on top, meaning that they have 4 carbons and 10 hydrogens. The bottom molecule has 4 carbons and 10 hydrogens. Count them at home to see that this is correct. Now, understand that the atoms are not arranged in the same manner. So even though these two molecules share the same chemical formula, the attachment of the atoms is different. If we look at the molecule in the bottom, we have a different longest continuous chain of carbons. So if I highlight these atoms, as you can see, we have as the longest continuous chain this 1, 2, 3 carbon atoms. A different arrangement that we can have for them is 1, 2, 3. Regardless of the arrangement that we pick, the one that was highlighted in green or the ones that was highlighted in orange, both contain as the longest carbon chain 3 carbons. So that means that the name of this compound, the last word that we're going to write, is the longest carbon chain, which is propane. And then I'm just going to erase now the highlighted portions. Understand that substituents are going to be the side group or branch that extends from that longest carbon chain. So let me just highlight at least one of the 2 arrangements that I illustrated. I'm going to highlight the first one. So that group that is outside of that longest carbon chain, which is known as the substituent, in this case is going to be this CH3 group. That CH3 group, its name is going to be methyl. And if we number the longest carbon chain, this is carbon 1, carbon 2, carbon 3, that methyl group is going to be located on carbon 2. So the name of that bottom compound is 2-methyl propane. Let's first learn the name of the most common substituents that you are going to be encountering in this class. So, as I just mentioned, substituents are atoms or group of atoms that are attached to the carbon chain and include alkyl groups and halo groups. So, for the purposes of this course, the substituents that you need to know are outlined in table 11.5. So, one of my suggestions will be memorize substituent list on table 11.5, because those are the ones that you guys are going to be encountering most often when it comes to organic chemistry in this course. So as you can see, if your substituent is only 1 carbon, as you can see, that carbon is going to be attached to 3 hydrogens, and that bond that is empty is going to be the connection to the main chain. Just wanted to illustrate that. Then this CH3 group is called a methyl group. If we have 2 carbons in a row, the last carbon, which is a CH2, will be bonded to the main chain, and that is known as an ethyl group. 3 carbons in a row, if as you can see, the one at the end, that CH2 is bonded to the chain to the main chain that is known as a propyl group. If you still have 3 carbons, but now the attachment to the main chain is through the second one, that is known as an isopropyl. The other type of substituent that we will be encountering in this course that is not formed, or they are not formed by carbons and hydrogens, are the halogen groups. As you can see, for fluorine, we call it a fluoro group. Chlorine, we call it a chloro group. Bromine, we call it a bromo group. And in iodine, we call it an iodo group. Remember, as you can see, for the ones that I underlined, because they are known as alkyl groups, meaning groups that have carbon atoms attached to carbon chains, their ending is in YL. When we have halo substituents, like the ones that we have at the bottom of the table, understand that they're going to have a specific name and is given by the second column in the table. Now let's explore on how to name an alkane given its structure. The first type of alkane that we're going to learn how to name is going to be ones that have only one type of substituent. Now, you guys are going to see that as we progress in organic chemistry, we are always going to have the first rule of naming being the one that we have in step 1 in this slide. So get used to the idea that the first step in every functional group that we're going to study is going to be finding the longest carbon chain of atoms in your functional group. In this case, because we're dealing with alkanes, you need to write the name of that alkane. So you can see, if I highlight the longest chain of carbon in this molecule, because there are 6 carbons, that's why we have hex as a prefix. So remember, this hex represents the number of carbons in the longest continuous chain. So we also call those the parent chain. So because we're dealing with alkanes, that's why the ending is in ane. So this symbolizes that we're dealing with an alkane. The second thing that we're going to do is going to be numbering the carbon atoms starting from the end that is nearest to a substituent. That's why when we are numbering this particular compound, we're going to do it from right to left. Then we're going to give the location and the name of each substituent. In this case, we only have one in alphabetical order. And we're going to give that as a prefix to the name of the main chain. So as you can see on carbon 2, we have a CH3. A CH3 is known as a methyl group. So that's why when it comes to the name, it's going to be 2-methylhexane. One of the things that I want to start specifying when it comes to naming, understand that this is one word. And if we need to separate numbers and letters, so numbers and letters are separated by a dash, always. So let's explore, given some structures, how will we apply these rules. So now we are going to go through the first 3 molecules that we have in Part B in our worksheet, okay? So I'm going to always use a highlighter to show what is the longest carbon chain. And then we are going to, again, number this longest carbon chain to give the substituents the lowest number, and then we're going to write the name of the compound. So as you can see, this molecule that we have in the first instance, the longest carbon chain is going to be this one, okay? If we number this, it doesn't matter if we number it right to left or left to right, it's going to always have that methyl group on carbon 2. Let me illustrate that. So if I number this 1, 2, and 3 from left to right, if now I number it from right to left, this is 1, 2, and 3, regardless, as you can see, that methyl group is located at carbon 2, so that means that I can number it either way. So the name of this compound is going to be on position 2 dash, because then I'm going to write a word. I have a methyl group. Because my longest carbon chain is 3 carbons, the prefix is prop, and because I have an alkane, it's going to end in ane. So this is 2-methyl propane. Let's move on to the next compound. Now, you must practice at home how to find the longest carbon chain. Please don't get used to just choosing the longest carbon chain for molecules as just what you see left to right. The longest carbon chain can be found in any type of arrangement. So, for example, in the second molecule, my longest carbon chain is going to be going from right to left, down to the side. Because if you choose the one on top, that's only 3 carbons. And remember that the goal of this is finding the longest carbon chain. So in this case, it's going to be 4 carbons. Now, I can number this in 2 different ways. I can number this as 1, 2, 3, 4, or I can number this as 1, 2, 3, 4. As you can see, the red arrangement gives it a position of 3, while the blue arrangement gives it the position of number 2. So in this case, the one that it is correct is going to be the blue arrangement. And I'm just going to re-highlight my longest carbon chain. So this molecule, again, we are going to be writing what is my substituent, which is what's outside my longest carbon chain, which this is a methyl. And when I'm writing the name of this compound, I say the location of the methyl, number 2, the name of the substituent, methyl, longest carbon chain prefix, bute, and then because this is an alkane, it's going to be 2-methylbutane. Let's deal with the last molecule. We're going to be selecting the longest carbon chain. In this case, is going to be the carbons that we have from left to right. As you can see here, is going to be 5 carbons. I'm going to directly number them to give that bromine, or in other words, this is my substituent, this bromo substituent, the lowest number. So when I number this from right to left, I go 1, 2, 3, 4, 5. So at position 2, I have a bromo group. Because I have 5 carbons in a row, this is going to be pent, and then this is an alkane, so it's going to end up being pentane. Let's now learn how to name alkanes that have 2 or more but of the same substituent. So as you can see, we have the condensed formula for the compound, and we have the skeletal formula for the same compound. Make sure that you learn to practice condensed and skeletal formulas when you are at home. Now, as you can see, as I mentioned before, the first step is always going to be finding the longest carbon chain of carbon atoms. In this case, because we are dealing with alkanes, we're going to give it the alkane name. So, in this molecule, as you guys can see, the longest carbon chain is going to be 6. Now, we can number this in the magenta arrangement or the blue arrangement. Remember, because on step 2, we want to number the carbon starting from the end that is nearest the substituent, the magenta arrangement we want to give the carbon atoms the lowest substituent. That's why the magenta arrangement is the correct one, okay? Because we will have those methyl groups on 2 and 4, and in the blue arrangement, they're on 3 and 5, okay? When there are, on step 3, when there are 2 or more of the same substituents, a prefix before the name of the substituent of di, tri, or tetra is used in front of that substituent name. Then, we have to give the location for each one of those substituents, and we have to separate them by using a comma. So this molecule that we have, its skeletal structure, as you can see in the bottom, it's going to give us the longest carbon chain because there are 1, 2, 3, 4, 5, 6. That's where the hex prefix comes. This is an alkane, that's why it's hexane. On carbon 2 and on carbon 4, we have methyl groups. So remember, we have 2 of the same. That's why we use the prefix di, and we have to give the location of each. So on carbon 2, we have 1. On carbon 4, we have the next one. And remember, numbers are separated by a comma when we are naming any type of functional group. So let's move on and let's do some problems to look at how to name these molecules, okay? So I'm going to just do the first 2 and make sure that you practice the third one and you check your answer in the answer key that has been posted on the Canvas site for the course. So remember the rules. Rule number 1, we're going to find the longest carbon chain. It happens to be that in that first molecule is going to be from left to right. If you select the longest carbon chain from left to right, moving down, it gives you the same answer. Understand that there's going to be different ways in which we're going to find the longest carbon chain. So I'm going to select the green arrangement that I had first. So I highlighted my longest carbon chain. Remember that my longest carbon chain is going to be the last word in my name. 4 carbons on a row is going to have a prefix of bute, because this is an alkane, is going to be butane. Then when I number this, I have 2 choices, right to left and left to right. If I do left to right, then this is carbon 1, carbon 2, carbon 3, carbon 4. If I do right to left, we have 1, 2, 3, 4. So the blue arrangement is the correct numbering because it gives my substituents the lowest number. So as you can see, my substituents in this case are going to be the same, and they are CH3s. CH3s are called methyl group. So before the longest parent chain, I'm going to write the name of the substituent, which is methyl. Okay. I need to determine or to write down a prefix that symbolizes how many methyls do I have. So since there's 2, we're going to add the prefix di. And then we are going to write down that they both live on carbon 2. So we're going to say 2, comma 2. And because we are separating numbers and words, then we're going to put dash, dimethylbutane. Let's go through the second example. We're going to find first the longest carbon chain, which I highlighted in green. Now, I'm going to go directly into having the lowest numbering for the longest chain. So again, I'm going to number that longest carbon chain to give the substituents the lower number, or the lowest arrangement of numbers. So this is going to be carbon 1, 2, 3, 4, 5, 6, 7. Okay, so since my longest carbon chain has 7 carbons, the prefix for 7 is going to be hept. I have an alkane, so this is heptane. As you can see, I have chlorines as my substituents. And chlorine, when it is a substituent, is known as a chloro group. So I'm going to write the word chloro. Because I have 2 of them, I'm going to say dichloro. And then I'm going to write hyphen in the positions of those chlorines. Carbon 2 and on carbon 4. Make sure that you practice with the third example at home and you check the answer key. Let's now move to alkanes that have different substituents, okay? As I mentioned before, when we move through these, understand that the first rule is going to be finding the longest chain of carbon atoms. In this case, because we're dealing with alkanes, we're going to give the alkane name for it. So, as I established before, when it comes to this and we have found the longest carbon chain, we should number it in the different arrangements to make sure that our substituents are going to have the lowest number possible. Now, if we look at our molecule, again, we have on the top of the words towards the left side of the slides, we have the condensed structure. And this is the skeletal structure for the compound. Now, when it comes to this, as you can see, we have the magenta arrangement and we have the blue arrangement. In this case, we have 2 different types of substituents. The one on the top is called a methyl group. The one on the bottom, that's called an ethyl group. So, when it comes to the blue and the magenta arrangement, as you can see, they are going to give on the position for those substituents that are going to be on either carbon 3 or carbon 5. So, when you have to decide how to give the numbering and you have the same numbering for your substituents, that's the only time where alphabetical order will precede numbering. Numbering is always going to be the rule of thumb. That's step 2. We're going to number the carbon atoms from the end that is nearest the substituent. I'm just going to write a note. In this example, the numbering for the substituents is the same, meaning they live on number 3 and number 5. Because of that, then alphabetical order of substituents will determine the correct numbering. Again, this is very special for this example. In general, this is not going to be your first rule. The first rule always is going to be, you're going to be numbering the carbon atoms starting from the end that is nearest a substituent. In this example, in the slides, because the numbering is the same, then alphabetical order is going to break the tie. Then we're going to give the location and the name of each substituent in alphabetical order as a prefix of the name of the main chain. And as you can see, for this compound, the name is going to be 3-ethyl 5-methyl heptane. Let's do a couple of examples to understand how to name molecules that have different substituents present. Okay, so when it comes to this, for example, I'm going to do only the molecules on the left side, the top and the bottom. Make sure that you practice the molecules that we have on the right side, top and bottom, and double check your answers with the answer key. So when we look at the top molecule on the left side, let's first highlight the longest carbon chain. So we have, starting from the left, 1, 2, 3, 4, 5, 6, 7, 8. Another arrangement that you can have for the longest carbon chain can be 1, 2, 3, 4, 5, 6, 7, 8. Both of them are going to be correct. So you just pick the one that it is more convenient or easier for you to see. Okay? They will give you the same name for the compound. I'm going to pick the one in orange to name this compound. As you can see, anything that is outside that highlighted longest carbon chain is going to be specifically my substituent. So in this case, I'm going to have two substituents. I have a CH3, and we already learned that that is called the methyl group. I have a propyl group because I have 3 carbons in a row, and since I'm attaching by one of the ends in these 3 carbons, that's why this is a propyl group. Then, once I know the name of my substituents, okay, we can number this carbon chain in order to give those substituents the lowest number. For this molecule, I'm just going to choose a different color to number it. If we number it from left to right and up, this is going to be carbon 1, carbon 2, carbon 3, 4, 5, 6, 7, 8. So that means that the name of my longest carbon chain is going to be octane. Then I need to put my substituents in alphabetical order. So I have to say on carbon 3, I have a methyl group. On carbon 5, I have a propyl group. And that is, they are attached to an octane longest continuous chain. Let's move on to the bottom left molecule. Let's first select what is the longest carbon chain. In this case, remember, you have to find the longest carbon chain. Many of you have to practice finding the longest carbon chain because you're going to be assuming that you go left to right and you're done, and that is not true. So when we're finding the longest carbon chain, remember, you need to find the longest continuous chain. So for this bottom left molecule, we have 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6, 7, 8. If you selected as your longest carbon chain just the one that is left to right, that is not the longest carbon chain because that is only 1, 2, 3, 4, 5, 6, 7, and that is incorrect. So the longest carbon chain in this molecule is going to be 8. And then here, as you can see, we have 3 different substituents. I'm going to circle them and then I'm going to name them. So we have a CH3, we have an F, and we have a CH2CH3. The CH3 is called a methyl group. The fluorine is called a fluoro group, Fluoro. Then we have a CH2CH3, which that is called an ethyl group. Then now we're going to proceed to number this longest carbon chain to give these substituents the lowest number. So in this case, we need to go 1, 2, 3, 4, 5, 6, 7, 8. So for this molecule to write the name, remember, we're going to write last the longest carbon chain name, which is octane. We have 3 different substituents and we have to put them in alphabetical order. So the first one that is going to come in is going to be that ethyl group. So we have 5, on position 5, we have an ethyl. Then on position 4, we have a fluoro group. On position 2, we have a methyl group, and all of these 3 substituents are attached to the longest carbon chain, which is an octane. Now let's practice, if you are given a name, how we are going to draw a structure. So we just learned to go from structure to name. Now we are going to reverse the process. As you can see, we have the following name: 1-chloro-2,2-dimethyl-heptane. Let's break down what the name is referring to. So as you can see, the 1-chloro tells you that there's a chlorine on carbon 1. The 2,2-dimethyl means that there are methyl groups on carbon 2, and there's actually 2 of them. And then our longest carbon chain, because it is a heptane, it has 7 carbons on a row. So when we are doing this, we have to take into consideration, okay, I'm going to draw first my longest carbon chain, which is going to be that heptane. So I'm going to first write the condensed structure for this name, which is going to be 7 carbons in a row. 1, 2, 3, 4, 5, 6, 7. Then I know that carbon 1, again, to my convenience, just because we read in English from left to right, I'm going to put on carbon 1, and I'm going to put it in a different color. On carbon 1, let me just assign it to the same colors that they have here. That would be easier for everyone. So carbon 1, we have a chlorine. Then carbon 2, we have 2 methyls. CH3, CH3. Okay? Now I'm going to fill in the hydrogens in the molecule. So as you can see, the first carbon is bonded to 2 atoms. So that means that it's going to be receiving 2 hydrogens to complete its octet. The second carbon, I'm just going to erase those highlights. So if you write H2C or CH2 is the same thing. Carbon number 2, it is bonded to 1, 2, 3, 4 atoms, so it doesn't receive any hydrogens. If we look at the next carbon, is only bonded to 2 groups, so it's going to be receiving 2 hydrogens. And the following carbons are going to be doing the same. The last carbon, because it's only bonded to 1 atom, that it needs to receive 3 hydrogens to complete its octet. So that will be the condensed structure for the name that it is given. How about if we want to write the skeletal structure? Remember, when your writing utensil touches the paper, that is going to be carbon 1. Then we are going to zigzag, meaning we're going to create hills and valleys to represent the carbon atoms that are present. Remember that in a skeletal structure, we are not going to be writing explicitly the carbons and hydrogens. We are just going to put any atom that is not carbon and hydrogen. So you can see in the skeletal structure, The minute that my writing utensil touches the paper, that is going to be carbon 1. And then I'm going to create a hill. That's carbon 2. Down, carbon 3. Up, carbon 4. Down, carbon 5. Up, carbon 6. Down, carbon 7. Then the reason why we are going to be zigzagging like this is because these carbon atoms are tetrahedral, and that's the geometric conformation that they adopt. So I'm going to now name or number. So this is carbon 1, 2, 3, 4, 5, 6, 7, which that is the heptane. As you can see, we have a chlorine and carbon 1. So I can just write a bond to a chlorine. And on carbon 2, we have 2 methyl groups. So a line is going to represent that there's a methyl, because remember that at the end of this, we're going to have a carbon. So in this skeletal structure, until you guys get used to it, I'm going to be darkening the dots, symbolizing that those are going to be carbons and those carbons are going to be hydrogen. So that is the structure, the skeletal structure for the following name. Let's practice by drawing the condensed and skeletal formulas for the following molecules that we have on part C of the worksheet. Now, I'm going to be doing specifically Roman numeral 1 and Roman numeral 2. So first, I'm going to be writing the condensed structure, followed by the skeletal. And make sure that you practice the remaining problems. So if I dissect the name, as you can see, I start with heptane, my longest carbon chain. 1, 2, 3, 4, 5, 6, 7. Then I know that in this heptane, and again, I'm numbering it to my convenience. Since in English we read left to right, I'm just going to number it 1, 2, 3, 4, 5, 6, 7. The name tells me that I have a substituent on position 4, and that substituent is a propyl group. So on position 4, since I know that I need to write a propyl group attached to carbon 4, I'm going to do CH2, CH3, CH2, CH2, CH3. Because when we have a propyl group, the last carbon is going to be missing a hydrogen, and that's what's going to be attaching to the main chain. Then I need to complete the number or the octets for each one of the carbon atoms. Carbon 1 only has 1 bond. That's why it receives 3 hydrogens. Carbon 2 needs 2 hydrogens. Carbon 3 needs 2 hydrogens. Carbon 4 only needs 1. Number 5 needs 2 hydrogens. Number 6 needs 2 hydrogens. And carbon 7 needs 3 hydrogens. If I write the skeletal structure of this molecule, as my writing utensil touches the paper, I'm going to say carbon 1, up, carbon 2, down, carbon 3, up, carbon 4, down, carbon 5, up, carbon 6, down. Let me start again. The program decided to do something else. We have 1, 2, 3, 4, 5, 6, 7. And then I'm going to number my carbon atoms. 1, 2, 3, 4, 5, 6, 7. On carbon 4, I have 1, 2, 3 to represent that propyl group. So that represents that group. Then I'm going to do 2-methyl-nonane. I'm going to do it right here below. Nonane tells me that I have 9 carbons in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my nonane. Then I know that on position 2, I have a methyl. So on position 2, I have a CH3. Then I have to make sure that in my condensed structure, I fill in with hydrogens the spaces that carbon have in order to complete their octet. So the first carbon is only bonded to one atom, so that's why it receives 3 hydrogens. Carbon number 2 has 3 lines, so it only gets 1 hydrogen. Carbon 3, it has 2 bonds, it gets 2 hydrogen. The same thing is going to happen to the remaining carbons until we get to carbon 9, because it's only attached to one more atom, it receives 3 hydrogens. Okay, so when we draw the skeletal structure for this molecule, again, we're going to, our writing utensil is going to be counting carbon 1, then we're going to go 2, 3, 4, 5, 6, 7, 8, 9. And then on carbon 2, we're going to have a methyl. So this is the CH3 that we have in the molecule. And then the 9 carbons are 1, 2, 3, 4, 5, 6, 7, 8, 9.